This is the video solution set to solving a system by graphing. And I'm going to point out to you we have two linear equations and two unknown variables. A system of two equations and two unknowns is a solvable system for the most part. You'll see what we mean by that. I'm going to do a couple things here. I'm going to say, let's let that first equation be represented by line 1 for L1. And then I'm going to have the second equation be represented by line 2 or L2. Since this is about graphing here, we need to actually put each equation in slope-intercept form, meaning y equals mx plus b, and then we're going to graph each equation. And the idea here is to find the point, remember, a point of intersection. A point of intersection has an x and y coordinate value. So this is what we're going to do. We're going to actually use our slope-intercept form to graph and find, hopefully, a point of intersection. Okay, here we go. So for the first equation, this is L1. Let's actually solve for y. We have x plus y is negative 4. We're going to subtract x from both sides. And we get y equals negative x minus 4. This is the first equation that we're going to graph. We call it L1. Now let's find the second one. L2. L2 is x minus y equals 0. So for the second equation, let's move this up a bit. X minus y equals 0. We're going to solve for y. I'm going to add y to both sides this time, and I get x equals y, or y equals x. Here's my second equation. Let's recall we're going to have to graph these two, and we are going to see the point of intersection. So it looks like we're going to need some graph paper. So let's note what we have. L1. Y equals negative x minus 4. Line 2. Y equals x. Okay. Let's get some paper. Okay, so let's remember we have our x-axis and our y-axis. Now, the first equation we're going to look at in purple, and notice I start at a y-intercept of negative 4. So I'm down 4 units. So this is the location of negative 4 in the y-axis. Then I'm going to use a slope value of negative 1. Since my slope is negative 1, I go down 1 and to the right 1. This is the location of my second point. We need our ruler because we're going to draw a line. Let's hope we can get the iPad to cooperate. Okay. Okay, let's hope we can get the iPad to cooperate. Cooperate, iPad. Hope this is good enough. Okay. This here is my first line. Now let's look at the next line here. We'll paint this one in blue. Line 2 is y equals x. So y equals x has a y-intercept at 0, the origin. This is where we start. And it has a slope of positive 1, so I go up 1 to the right 1. So the next point of intersection is where you see here. Let's draw a line. Okay. As you can see, it looks as if the point of intersection is right here. Now, to read this, that looks to be -2 and another -2. So our point of intersection here looks to be where x is -2 and y is -2. This is where my point of intersection is. -2, -2. Now, let's note here. The x-coordinate is -2, and the y-coordinate is -2. If I plug in -2 for x in the second equation, I better get -2 for y. And sure enough, this relationship is true. If I plug in -2 for x, I better have a -2 here for y. Now let's notice what happens in line 1. Okay, line 1, let's keep this, should be -2 equals minus a -2. -4. Let's double check. -2 is +2 minus 4. -2 is -2, sorry. Sure enough, this is the location of my intercept. The point and coordinates of -2, -2. This point P satisfies both equations. We are done. Okay, number 3. Number 3, we have x plus 2y is -2. X plus y is 1. Notice we have our first equation and our second equation. They're going to be represented by line 1 and line 2 respectively. So let's look at line 1. Let's look at the work. X plus 2y is -2. Subtract x from both sides, and you end up with 2y is -x minus 2. We're going to divide both sides by 2. We end up with y being -x divided by 2 minus 2 divided by 2, or y equals, put it over here, -1/2 x minus 1. This is our first equation. Line 2. X plus y is 1. I'm going to solve for y here again. Subtract x. We end up with y equals -x plus 1. So notice what we're going to do here. Let's go up. This first equation, I'm going to draw an orange. I'm going to draw a line representing that first equation. I'm sorry, that's not orange, that's purple. The second equation, we're going to draw in blue. with a blue line, and we're going to find a point of intersection. So we're going to need a graph here. So let's get a graph. Okay. We have an x-axis, we have a y-axis. Let's see what that first equation is. It's negative x, oops, sorry, too far up. It's negative 1/2 x minus 1. Okay, so maybe it is a good idea for us to draw this first equation here. Let's put it right here. Y is negative 1/2 x, let's double check, minus 1. And the blue equation we'll put as y equals negative x plus 1. Alrighty. So let's do the first equation here. And let's notice here that we have a y-intercept value of negative 1. So that's down on the y-axis here at 1, and now we're going to use a slope of negative 1/2. That means I go down 1 to the right 2 for the location of my second point. We're going to draw our line. Okay, let's be careful. Here's our line. Call that L1. Now let's find L2. We have a y-intercept at positive 1, so I go up 1. And now I have a slope of negative 1. I go down 1 to the right 1. So the location of my second point is right here. Okay. Let's draw our line. This is the second line. If we look closely here, the point of intersection probably is at this point here. Let's determine what this point P is. The x-coordinate is 1, 2, 3, 4. So it looks like we go 4 to the right, and then 1, 2, negative 3 down. This is my intersection point. And if you like, you could go back and plug in these values and verify that x is 4, y should be negative 3. If x is 4, y should be negative 3. You can verify these values, but the point of intersection is at 4, negative 3. Number 5, we have 2x plus y is negative 4. We have x minus y is positive 1. Line 1, line 2. Let's do the work. Let's solve for y. 2x plus y is negative 4. We subtract 2x from both sides. We get y equals negative 2x minus 4. X minus y is 1. Subtract x from both sides. You get negative y is negative x plus 1. And if you like, Well, not if you like, you have to. Divide both sides by -1. -1 cancels, and you end up with y equals -x divided by -1 plus +1 divided by -1. We'll get y equals x minus 1. These are the two equations. So let's write them down. Y equals -2x minus 4. Y equals x minus 1. Line 1 and line 2. We're going to graph the first line in purple and the second line in blue. X-axis, y-axis. Here we go. We're going to start at -4 on the y-axis for the first line. So we go down 1, 2, 3, and 4. So location of my y-intercept, we're now going to use a slope of -2. Go down 2 to the right 1. Let's draw our line. This is line 1. In blue, we're going to start at -1. We're going to use a slope of +1. So let's make sure we plot the y-intercept. You use our slope up 1 to the right 1. This is the location of my second point. Okay, iPad, let's cooperate. Here we go. Let's draw lines. As you can see, you look to have a point of intersection right there. This is where my point is. It's to the left -1. It's down 2 units. -1, -2 is my point of intersection. Okay. This was number 5, which means we're now on number 7. (3x plus y) is 6. X minus 2y is 2. Line 1 and line 2. Let's do the work. We're going to have to solve for y. So let's subtract our 3x from both sides. Then you get y equals -3x plus 6. Here's my first equation. Second equation. Hold on for a second. Let's put on mute. So I have x minus 2y is 2 I have to solve. Here's what I'm going to do. I'm going to do something a little different. I'm going to add my 2y to both sides here. I get x equals 2y plus 2. I'm now going to subtract 2 from both sides. We get x minus 2 is 2y. Divide both sides by 2. we'll get x over 2 minus 2 over 2 is y, or x over 2 minus 1 is y. Here's my second equation. Y is 1/2 x minus 1. Now, we're going to actually draw a purple line for L1 and a blue line for L2. Let's write down what we have. Y is negative 3x plus 6. That's line 1. Line 2 is y is 1/2 x minus 1. Again, blue, purple. We need a graph. Okay, we have the x-coordinate, the y-coordinate axis. Let's graph. Purple. Our y-intercept is at positive 6. 1, 2, 3, 4, 5, and 6. Here's my location. We're going to use a slope of negative 3, so it means I go down 1, 2, 3, and to the right 1. This is the location of my second point. Let's draw our line. In blue. The y-intercept is at negative 1, so we're down 1. And then we're going to use a slope of 1/2. That means go up 1 to the right 2. This is the location of my second point. We're now going to draw our line. Whatever that was. Let's find the point of intersection. Looks like my point of intersection, P, is right there. The address is x is 2, y is 0. That's where 2 is. This is the point of intersection, 2, 0. Remember, we have line 1 and line 2. Number 9. Two x plus 3y is 3. X minus y is negative 6. Okay. I'm going to draw the first line in purple, and you're going to draw the second line in blue and find the point of intersection. So let's get to work and solve each equation for y. 2x plus 3y is 3. Subtract 2x from both sides. 3y is negative 2x plus 3. Divide both sides by 3. Y is negative 2x over 3 plus 3 over 3, or y is negative 2/3 x plus 1. Here's my line 1. X minus y is negative 6, I want to start solving this by adding y to both sides. And I get x is y minus 6. I'm going to now add 6 to both sides. And you get x plus 6 is y. Or you get y equals x plus 6. Here's line 2. So let's note line 1 and line 2. Line 2 is x plus 6. Negative 2/3 x. Okay. Line 1 is negative 2/3 x plus 1. We're going to graph these. Purple. Oops. Sorry. Blue. We're going to look for our point of intersection. Graph the first line in purple and the second line in blue. Okay. Let's bring some graph paper here. Pretty weird. Okay. X-axis, Y-axis. We're going to start at the y-intercept at positive 1. This is the location. And then we're going to use a slope of negative 2/3. So I'm going to go down 2, 1, 2, and to the right, 1, 2, 3. Here's the location of my second point. This is line 1, line 2. We're going to start at positive 6. 1, 2, 3, 4, 5, and 6. This is location of my y-intercept. We're going to go up 1 to the right 1. And find the location of my second point here. This is line 2. So if we look closely, our point of intersection is right here. It's where x is negative 1, negative 2, x is negative 3, y is positive 1, 2, y is positive 3. So negative 3, positive 3 is the point of intersection. Number 11. 2x minus y is negative 3. 4x minus 2y is negative 6. We've got line 1 and line 2. let's get to work. We're going to solve both equations for y. Now, I'm going to subtract 2x from both sides for this one, just so we can see variation again about how to solve. And remember, now I'm going to divide both sides by -1. I get cancellation. Y equals -2x divided by -1 minus 3 over -1. And y would be 2x plus 3. This is line 1. Line 2, remember, is 4x minus 2y is -6. We're going to subtract 4x from both sides. We get -2y is -4x minus 6. Divide both sides by a -2. Y will be -4x over -2 minus 6 over -2. Y is 2x plus 3. So let's notice what the lines are here. Line 1 and line 2. 2x plus 3 and y is 2x plus 3. Now, if you notice something interesting here, this is the same line. And if you remember from class, what we said here is the following. Let's bring in our graph. Let's go through the details. May be necessary, may not be. X-axis, y-axis. I'm going to graph, if I want to think of it that way, one equation in purple and the other in blue. And when I start to graph this, let's start to do the purple one. You say, okay, we have a y-intercept at +3. 1, 2, 3. Here's the y-intercept. We have a slope of +2. So go up 2, go to the right 2. Let's draw our line. Line 1. If I repeat the process now in blue, notice again, I start at 3, and my next point is at that same location, and I draw my line yet again, this time in blue. This line is right on top of the other line. Now, what this means is the following. It means that this point is a solution, this point is a solution. In fact, there's many points on this line that are solutions. Since there's infinitely many points on a line, what we say here is simply that there's infinitely many solutions. Infinitely many. And very often textbooks will describe this scenario in set notation, and actually it's really not the set of all x anymore, it's the set of all ordered pairs or points xy such that y equals 2x plus 3. In other words, this set notation describes every one of these infinitely many solutions that are on this particular line. So this is how we answer the question, and this is a special scenario. We're talking about the same exact line, and they intersect everywhere on that line at infinitely many points. And this is number 11. Yeah, let's double check. Number 11. So it means number 13. X plus 4y is negative 4. 2x plus y is positive 6. Line 1 and line 2. Line 1. X plus 4y is negative 4. I'm going to subtract x from both sides. We get 4y is negative x minus 4. We're going to divide both sides by 4. Y is negative x over 4 minus 4 over 4. Y is negative 1/4 x minus 1. Here's our first equation. Second equation, 2x plus y is 6. We're going to solve this equation for y. Subtract 2x from both sides. Get y is negative 2x plus 6. Here's the second equation. So let's note. We just got the second equation. Negative 1/4 x minus 1. Here's my first equation. Okay, let's start to graph here. X-axis, y-axis. First equation we'll draw in purple. Second will be drawn in blue. Start at negative 1. That was the correct place. Start at negative 1. We're going to go down 1 to the right 4 because that's our slope. Down 1 to the right 4. Line 1. Line 2. We're going to start at positive 6. 1. Let's see. 1, 2, 3, 4, 5, and 6. And our slope now is negative 2, so that means we go down 2 to the right 1. This is the location of our second point. Let's draw a line. This is line 2. The point of intersection is down here. Let's see if we could determine the address. 1, 2, 3, 4. Here we go. X is 4. Y is negative 2. The address is 4, comma, negative 2. This is our point of intersection. Number 15. 2x minus 3y is 6. 2x minus 3y is negative 9. Line 1 and line 2. Let's get to work. Line 1. 2x minus 3y is positive 6. We're going to add 3y to both sides. And you get 2x is 3y plus 6. Divide both sides by 2. Sorry. We're making some mistakes here. I'm going to subtract 6 from both sides. You get 2x minus 6 is 3y. I'm going to divide now both sides by 3. My 3's cancel. Make sure 2x over 3 minus 6 over 3 is y. Let's see what you get. Y is 2/3 x minus 2. That's our first line. Let's see the second line. Two x minus 3y is negative 9. I'm gonna solve this one a little differently to show you again the variation of how to solve. It can be done in more than one way. So I'm actually solving for y. I'm now going to divide both sides here by negative 3. So notice I started to subtract 2x from both sides this time. And we could do that. We're experts now at solving these equations. So notice I get negative over a negative gives me a positive. And here's my second line. So let's kind of note where we're at. So note we have to graph line 1 and line 2. Line 2 we just solved for. Let's write this a bit better. Y is 2/3 x. Y is 2/3 x plus 3. And then down here, y is 2/3 x minus 2. Okay. Well, let's try to see what we can do here with this. Okay, let's see if we can move this. That's funny. Okay. Let's try this again. Okay, let's try to get this to cooperate. Anyway, let's see what we can do here with this. These are our two equations. Let's try to enter a graph now. Okay. I think I know what's going on. Let's try this again. Here's what we're going to do. We have 2/3 x minus 2 and we have, I guess that was plus 3, yeah. Y is 2/3 x plus 3. Now, you know, we did talk about this in lectures, so you may notice something interesting about these two lines. We're still going to graph the first one in purple, and we're still going to graph the second one in blue. But notice again something very, very interesting. They have the same slopes. Remember, this is going to have some meaning for us. Same slope. We'll put it in red. Same slope. That means M1 equals M2. And in addition to the same slope, they have different y-intercepts. That meant something. Different y-intercept values. In other words, B1 is not the same as B2. This here has special meaning. Remember what it meant. Let's try to graph now. Let's see if we can enter a nice graph without it being picky and moody. I wonder. Yeah, I guess we're going to have to try to do it something like this. Okay. Let's see how this works for us, okay? Nevertheless, we have an x-coordinate, or the x-axis, and the y-axis. Now, if we start with the first equation, remember, everything in purple, we're going to start with a y-intercept at -2. So I go down 2 units. Here's my -2. I use a slope of 2, 3. I go up 2, to the right, 3. That's the location of my second point. We're now going to draw your line. Line 1. There's my first line. Now in blue, we're going to plot y-intercept at +3. 1. Let's go back. 1, 2, 3. Here we go. We're going to use our slope again of 2, 3. Up 2, to the right 3. Let's draw our line. This is my second line. Now let's notice again what this meant, what this means whenever we're in this scenario. Okay? When we have lines that have the same slope but different y-intercepts, these lines are parallel. In other words, L1 is parallel to L2. And as a consequence, these lines never intersect. There is no intersection. Now let's find a place to write this on the screen. Maybe down over here. There is no intersection. And because there's no intersection, we say there's no solution. A solution being a point of intersection. Since the lines are parallel and they never cross, again, the lines are parallel, they never cross. Therefore, there's no point of intersection. there's no solution. So some texts you'll see actually this symbol, set notation symbol, to describe no solution, meaning there is no point of intersection. And this happens always when you have lines that have the same slope but different y-intercepts. And that was number 15. Let's see 17. 2x minus y is negative 6. Negative 2x plus y is 12. Line 1 and line 2. Let's get to work. Line 1, 2x minus y is negative 6. I'm going to solve for y. I'll subtract 2x from both sides. We get negative y is negative 2x minus 6. Divide both sides now by a negative 1, where my negative 1's cancel. And I'll find that I have y is negative 2x over negative 1 minus 6 over negative 1, or y will be positive 2x plus 6. That's my first line. Line 2. Negative 2x plus y is 12. I'm going to add 2x to both sides. Y is 2x plus 12. Let's note what we have here. Line 1, line 2. Y is 2x plus 12. Y is 2x plus 6. If I look closely, they have the same slope. They have different y-intercepts. Let's put this in red. M1 equals M2. Same slopes. B1 does not equal B2. Different y-intercept values. These lines are parallel. Parallel lines have the same slope but different y-intercepts. Number 19. Is a determine the equation of the line. So again, let's go back and review. If they ever ask for the equation of a line, we always use point slope form. Remember, to use point slope form, you need a point and you need a slope. So let's write this in red. We need a point, we need a slope, hence point slope form. Here's my y-coordinate and x-coordinate for my point. Here's my slope. So in number 19, here's what they say to us. They want an equation of a line that passes through the point negative 3, comma 2. And that line is parallel to the equation 3x minus 4y is negative 12. So I want to point out to you one important detail. They gave us here a point. We have the x-coordinate and the y-coordinate of our point. So we just need the slope. Now going back up here, looking at point slope form. I'm going to plug in 2 for y1 and negative 3 for x1. that line has to be parallel to the equation here that's represented by a line. And remember, parallel lines have the same slopes. In other words, M1 equals M2. All I have to do now is actually determine the slope of this line, and I'm going to do that by solving for y and placing this in slope-intercept form. And that's how we do it. Negative 4y is negative 3x minus 12. Now, divide both sides by negative 4. Y is negative 3x divided by negative 4. Negative 12 divided by negative 4, I get positive 3/4 x plus 3. I need the slope value of 3/4. So using the slope of 3/4 here now, let's go back. Here we go. Replace m now with 3/4. So we got y minus 2 is 3/4 x minus a minus 3. Let's hope we don't forget that. Y minus 2 is 3/4 x minus a minus 3. Let's double check. Looks like this is what we have. Okay, here we go. Y minus 2 is 3/4 x plus 3. Y minus 2 is 3/4 x plus 9/4. We're going to add 2 to both sides. Y is 3/4 x plus 9/4 plus 2. 9/4 plus 2, I'm going to do some work. 9/4 plus 2 over 1. 2 times 4. 1 times 4. 9/4 plus 8/4 is 17/4. Final answer. Go back here. 3/4 x plus 17/4. And you're done. Number 21. Determine the equation of the line that passes through the point 0, negative 4 and is perpendicular to the equation 4x minus y is 8. Again, point slope form. They gave us a point, x coordinate, y coordinate. So we have a line that's perpendicular to another line. And remember, we're going to have to consider what this becomes. We get y minus a minus 4, or a negative 4 there, is m times x minus 0. We need the slope m. Now the slope here happens to be, let's note, perpendicular to another equation. 4x minus y is 8. Now let's recall the relationship between perpendicular equations. Before I do that, let's solve this for y here and get a handle on what this slope is, if we recall from lecture. Subtract our 8 from both sides. We get 4x minus 8 is y. Our y becomes 4x minus 8. this is going to be important for us. We're going to need to know the slope here of this line. Because if you recall, perpendicular lines actually have slopes that satisfy this relationship. In other words, when I multiply the two slopes together, the product is -1. What this really means is that the slopes are opposite in value. If one's positive, the other's negative, and reciprocal. If one has a slope of 1/2, the reciprocal of 1/2 is 2, or if the slope for one equation is 3/2, the reciprocal of 3/2 is 2/3. We went over this in class. So the point I'm making is going to be this. M1 we don't know, but M2 is 4. So I can take M1, if you want to call it M at this point, you can, but M1 times 4 better be -1. M1 times 4 is -1. If we solve for M1, divide both sides by 4, and you get M1 to be -1/4. This is the slope of the line that they're talking about. Now, you're going to note that M1 is -1/4, and M2 is +4. They are reciprocals and opposites, meaning the reciprocal of 4 is 1/4. The opposite of a +4 is a negative. So this is my slope. -1/4. That's what I'm going to use to plug in. -1/4. Right here. So we end up with y plus 4 with that -1/4. Here we go. Y minus a -4 equals -1/4 x minus 0. Don't need a parentheses. Y plus 4 is -1/4 x. Subtract your 4 from both sides. We end up getting y being -1/4 x minus 4. And you're done. (23) Determine the equation of the line that passes through 0, -5, and is parallel to the equation x plus y is 7. Again, point slope form. Y minus y1 is m, x minus x1. We have an x coordinate and a y coordinate. X1 is 0. Y1 is -5. We just need the slope. To get the slope, we're going to have to solve this equation here for y. Put this in slope-intercept form. So let's note x plus y is 7. Subtract x, subtract x. Y is -x plus 7. Where my slope value here is -1. Now, this is going to be important because remember, parallel lines have the same slope. M1 is the same as M2. So this value is -1. We end up with y minus a -5 is -1 times x minus 0. Or y plus 5 is -x. I'm going to subtract 5 from both sides. You end up getting y is -x minus 5. And you're done. 25. Determine the equation of the line that passes through the point 3, negative 4, and is perpendicular to the equation x minus y is 5. Again, point slope form. Y minus y1 is m times x minus x1. First point. Notice y1 is negative 4, x1 is 3. We need the slope. So we're going to have to solve this equation for y and put this in slope-intercept form. So let's note x minus y is 5. Subtract x. Negative y is negative x plus 5. Divide both sides by negative 1. Y is negative x over negative 1 plus 5 over negative 1, or y is x minus 5. Notice here what your slope is. Your slope is 1. Now, if the lines are going to be perpendicular, perpendicular lines, remember, are both opposite and reciprocal. So what that means is, let's write it down. The slope will be of a line that's perpendicular. The reciprocal of 1 is 1 over 1. Opposite is minus 1 over 1. So notice that this slope that we're looking for is actually negative 1. Because the reciprocal of 1 is 1. The opposite of a positive 1 is a negative 1. This is the slope I use. This is my m value. M is negative 1. Let's do the work. Y minus 4 is negative 1 times x minus 3. Y plus 4 is negative x plus 3. I'm going to subtract 4 from both sides. We get y is negative x minus 1, because 3 minus 4 is negative 1.